Okay, hello everyone, and welcome to my talk about React Native security, addressing typical mistakes. Actually, this is my first time speaking at such a large OWASP event, so let me quickly introduce myself. Uh, my name is Julia. I'm a security software engineer at Cossack Labs. I'm also a leader of OWASP Zhytomyr chapter in Ukraine, and I am a huge fan of OWASP, MASVS, and MSTG projects. Cossack Labs is a data security and cryptography company. We have products and expertise in different platforms and languages. And my personal specialization is mobile application security for iOS, for Android, and for React Native. We do not break stuff, we build it. And today I want to talk about things you need to consider to build a secure React Native application. We will talk today about the architecture in general, about platform-specific things for iOS, for Android, for React Native. We'll talk about dependencies and about security testing. And I would like to start with this phrase that choosing React Native and its components means that you understand and accept potential security consequences. To understand what it means, let's take a look at the architecture of the React Native apps. It's just a general overview. React Native is a cross-platform solution from Facebook that allows writing applications using React, JavaScript, and you can also use TypeScript. So we have native platforms, iOS and Android. We have JavaScript engine. It can be custom or it can be a native one. And we have these components, the bridge written by Facebook that handles messages between native platform and JavaScript engine. When you write native apps for iOS and Android, you choose to trust Apple and Google with their systems, with their APIs. You believe that they are secure enough for your applications. And when you use React Native, you add Facebook to this list. And if you decide to use TypeScript, you also add Microsoft. The problem here is that each new third-party component makes the attack surface wider. If the bridge is broken or Facebook stops supporting it or something else happens, your React Native app stops working as well. And the same problem goes with JavaScript engines. If you choose using custom JavaScript engines, you will need to deal with it as well. For example, Facebook has JavaScript custom JavaScript engine for iOS and Android called Hermes to make React Native applications more efficient. But you know, there are already found vulnerabilities in this Hermes JavaScript engine. Of course, they're already fixed, but still. These are vulnerabilities for Hermes for Android, and Hermes for iOS was just released this year. And there are still, it still looks good for now. Okay, moving forward. With React Native, developers deal with security for all three platforms, with iOS, with Android, and with React Native. I'm pretty sure you're familiar with mobile top 10 from OWASP, like similar to just OWASP top 10, but for mobile applications. And the first item in it is improper platform usage. And the sad truth is that if it's hard for iOS and Android developers to use platform-specific security controls, it is even harder for React Native developers because, again, you need to deal with specifics of all three platforms. I will show you multiple examples of this. I just love this phrase that React Native is a leaky abstraction. React Native allows you to abstract from the details of each native platform, but sometimes such details are very important from the security perspective. Let's take a look at several examples. The first one is Secure Store. It is a library from Expo that claims that it stores data encrypted. And well, that is true. It uses keychain on iOS that is an encrypted storage. And for Android, it uses key store to create a key. Then it encrypts the data with this key and stores it in shared preferences regular storage. Like all good here, it stores data encrypted, that's right. But you see, keychain persists its data across app reinstalls, while shared preferences do not. And there is an MASVS requirement that you need to erase the data across app reinstalls. So here we're missing this requirement. Then for iOS, we have hardware-backed encryption starting from iPhone 5S. That was released several years ago. And for Android, there are still devices that do not have hardware-backed encryption, and probably you don't want to run your application on such devices. Then, if you use keychain, your data is decrypted when your device is unlocked, meaning you use Touch ID, Face ID, or passcode, and then your data is stored in plain text until you lock your device. While on Android, this library decrypts the data just right before usage. And you see, there are differences in the behavior of this security control. And if you follow mobile security best practices standards, you want the behavior to be similar. You want to erase data across app reinstalls, you want to have hardware-backed encryption, and you want to decrypt your data just before use. So here you need to understand and fix these platform-specific things. Another example of platform-specific problem is about managing Android permissions. On Android, you specify permissions in manifest file. And each dependency may have its own manifest file adding new permissions. It is a common practice for React Native applications to have multiple dependencies. I'd say sometimes your application may have even more than 100 of dependencies, and each of them may add new permissions to your project. And it becomes a headache because you can remove some of these permissions. You can take your main manifest file and remove these added permissions, but it does not guarantee that the library can support it. Like it may just crash if you try to remove its permission. So dependencies are a headache, and we'll get back to this topic a little bit later again. Okay, one more example. Now it's JavaScript specific. It is maybe one of the most popular questions I hear is that is XSS possible in React Native? And the generic answer is its possibility is decreased by design. If you read some articles, you can see some explanations why we consider the possibility to be decreased, like in React.js, and for React Native, it is decreased even more. But let's not go way too deep into this topic because XSS is still possible. It's a very trivial example, but still, there's still this eval function. And here is an example that if you use async storage, you can pass this another library for storing data in mobile applications. You can pass these lines to the eval function, and these lines will take all the data from async storage and send it to this address. So yeah, that is possible. And another example. Things are getting even harder when we talk about jailbreak and root detection. This topic is not easy for regular iOS and Android teams, meaning native teams. And It is even harder if we want to talk about React Native because there is no ready-to-go solutions. Maybe there are some, you can purchase some solution, but I'm not even aware if such exists. You can try to implement your own, but I'm almost sure that it's not possible to use just JavaScript to do that. You will still need to go to the native code. And the second option is to use some third-party solutions that are already available for native platforms and to write bridging code for them. It may sound easy, but still there are some challenges. For example, this is a very, very good library for iOS security to detect jailbreak, and it follows all the recommendations from OWASP about protection against reverse engineering and tampering. It's called iOS Security Suite. This library is written in Swift, and I really like it and I recommend it. But the problem here is that, okay, you have this library for iOS, it's written in Swift, but by default, React Native applications use Objective-C. So you write bridging from Swift to Objective-C, and then you write bridging from Objective-C to React Native. A lot of work, and it's just for one platform. It's just for iOS where we have such a nice library. And I am not aware if there is any such a good Android library. You will have to use a couple of them, or maybe even write some code on your own. And again, bridge it to React Native. So it is a lot of work, a lot of pain, and requires a lot of platform-specific knowledge. Okay, getting back to the dependencies topic. A typical situation on React Native project. A lot of dependencies, and they bring a lot of vulnerabilities. This is a real life project I worked on. Yeah, we've created a task for the team that you need to update dependencies, you need to review these vulnerabilities and to do something with it, maybe remove some libraries or to do something. And sometime later, they have updated their dependencies, and we received that. Well, and it is after the update, and I'm not pretty sure what is better, to have 16,000 low vulnerabilities or 2,000 high. Well, so the next recommendation is just to remove these vulnerabilities with unfixable high issues. So monitoring dependencies is not that easy for React Native. You are forced to use a lot of them. You will have a lot of additional CI work. For example, dependency checkers are a must. And then when you'll need to update your dependencies, you should consider that one update triggers another update. You may need to do some architectural changes to your application. Updates may be incompatible, and you may face some vulnerabilities that just do not have a fix. So what should you do in such situation? First, we suggest you to understand the scope of such vulnerabilities, because sometimes these are just false positives. If you use React Native for iOS and Android, you should consider that it is also used for web, and probably you do not use web parts, so maybe web vulnerabilities are not relevant to your project. So you need to understand the scope of the vulnerability, document it, share with your team, because if you leave the project, someone will need to start reviewing this huge list from the very beginning. And of course, monitor and book time for updates in the future. And booking time here is really crucial. Another situation is when some vulnerability is fixed in the platform main native platform in iOS or Android. For example, when iOS decided to remove support of the UI web view because it was way too vulnerable. And so you wait for the update for the native part, then you wait until Facebook releases the update for the React Native. Then some teams have a forked version of the React Native repo, for example, to remove web part if they are not using it. So they need to update their fork. Then they wait until all the dependencies are updated, and only then you can work and update your own source code. So it's very, very time consuming. And the main rule here is always plan your time for updates. Now it is the last section of my talk about security testing of React Native apps. Because just a lot of people are asking me, well, how we do this. And of course, my common answer for mobile applications is using a Wasp MSVS and a Wasp MSTG. Yeah, hello again to Carlos and Sven here. It is Mobile Application Security Verification Standard and Mobile Security Testing Guide. And if you open the second one, you will see the note that it actually focuses primarily on native applications and does not have a lot of information for React Native, for Xamarin, Cordova, Flutter, and other so-called hybrid applications. But the good news is that you can still use MSVS because it is language agnostic. It is almost platform agnostic. All requirements are relevant for React Native applications because like React Native applications, they are like native under the hood. And you can still use MSTG because general ideas of the test cases, it is still similar. Like the major difference is that you may need to read JavaScript code, but in general, everything is still the same. You will still need to test keychain, as you've seen, key store, shared preferences, SSL pinning, TLS pinning is still implemented in native code the same way as before, settings to allow HTTP traffic are still mentioned in info plist file or network config. Like a lot of things are still similar. So testing is not that different for React Native applications. And a little bit to sum up this, how do we do this? How do we test React Native application security? First of all, yeah, we use MASVS. It's very convenient because it is a sort of checklist and it can make our security measurable, more visible. Then, as I mentioned before, we need to take a closer look on dependencies. We need to take this JavaScript code of dependencies and like written for React Native application by us and look deeper to understand what native API it uses, what security controls it uses. So it requires more effort here, like to go deeper. A challenge here is that, okay, now we have JavaScript code, and by default, the native code for React Native applications is written in Objective-C and Java that are not the latest tendencies, let's say. And the truth is that it is very likely that you will also deal with TypeScript together with the JavaScript. And it is very likely that you'll have to deal with Swift and Kotlin. So you see, instead of having like two languages, like in many other projects, Swift and Kotlin, you need to deal with 6 languages. And yeah, it's an additional challenge if you do security review, reviewing the code and giving some suggestions for secure coding for developers. So it's another challenge. And the last part of this is JavaScript specific vulnerabilities. You can just Google them. I think you will find some information about XSS mostly. Uh, but you can still take a look at Web Security Testing Guide and ASVS to find something that will help you to understand what JavaScript specific vulnerabilities may be present in React Native applications. And some final thoughts from me. So Facebook names their approach as learn once, write anywhere. But for me, it sounds more like learn once and ask mobile security people for help, because yeah, you've seen why. And a couple of useful links from me. The first one is my article about React Native application security. It has some additional details to my talk, so you can go here and read it. It has more details on architecture. Also, the second link is a security guide from Facebook on the official page. It's just interesting to read what do they recommend, and I can say that mostly it's the same things that you've seen from improper platform usage. These are all platform specific things, not that many React Native, like JavaScript specific things. And the third link is for OWASP SVS. Like as I mentioned, it does not have a chapter or recommendations for hybrid applications. But there is an ongoing discussion, and feel free to join it. We'll be glad to hear your thoughts. Like, how do you use it? How do you use MSVS for React Native applications? What are your suggestions? Please feel free to share your thoughts. Okay. And generally, that is it from me. This is my Twitter. You can follow me. I will post my slides in Twitter sometime later. And of course, I'm here in Slack chat, so I will be glad to hear your questions. Thank you.